This is for Year 12 Further Maths. We can look at 18F, question number 3. So 18F is to do with 3D trig problems. So it's really important that we have the ability to visualize. That's the key. And if you're struggling with visualizing, use things in your pencil case, like a pen or something, and a piece of string, to perhaps put a model on your table while doing the question, so you can get a better understanding of how to view it in 3D. So a tree stands as a quarter of a square of a playing field. Each side of the square is 100 meters long. At the center of the field is a tree subtended at an angle of 20 degrees. So at the center of the field, a tree subtends angle of 20 degrees. Okay, so it's shown in the diagram. What does it angle to subtend each other corner of the field? Okay, so we got to visualize this. Okay, because if the tree, what it's asking you is, if I go from the corner to the tree, what is that angle here? If I go from the corner to the tree, what is this angle here? If I go from the corner to the tree, what's this angle here? Okay, so we've got 3 different angles. These 2 angles will be the same because they're both from the edge to the tree. Okay, so if I draw visually what I'm showing you, this is the tree, that's 100 meters, that's the angle, and we want to find what that height is. Okay, so first things first, you've got to find what the height of the tree is, because there's no way we can do the problem, because this is running a triangle, so this is like a soccer tile problem. However, if I don't get the height of the tree, I can't work out what this angle is, because I'm missing this part, which is the height of the tree. Okay, so our first order is, if I draw the square, we need to figure out what this is. We need to figure out what this length is. Okay. So we know that this is 100. This is 100. If I figure out the whole hypotenuse, I'll call that whole hypotenuse y. Then I know that 100 squared plus, because this is a right angle, I know 100 squared plus 100 squared equals y squared. Okay, so I'm going to enter that on my calculator to solve for y. Remember, with measurement problems, we only want the positive solution. So if I go 100 squared plus 100 squared equals x squared, because I don't want to bother using y. Interactive and solve. Oops, select everything. Interactive and solve. I get 141.4214 meters. Now, x is half of y, so if I divide that by 2, so I'm going to copy it and divide that by 2, because I don't want to write too many steps on one page. So x would equal 70.710607. 70.7107. Okay, 70. X equals 70.7107. I know that, so this problem is quite long because I'm having to do quite a few steps. I know that the height of the tree, I'll call that T. I know that's 20 degrees. I know this is 70.7107. Now, if I use I'm using the triangle they've drawn there. If I use that triangle, I can solve for T, because I know that opposite adjacent. So that's 20 degrees opposite adjacent, so we're using a TOA ratio. So tan of 20 degrees equals opposite divided by 70.7107. Solve for T on the CAS calculator. So go CAS. So write tan, oops, cancel that. Tan of 20 equals x divided by, I'll just copy and paste this, interactive and solve for x, 25.7366. Okay, so t equals 25.7366. Okay, so we've got the height of the tree. Great. We can use the height here because I know the height of the tree now is 25.7366. Now all I do here is I calculate what the angle is. So the angle is given by, well, the tan of the angle is given by 25.7366 divided by 100. So theta equals the inverse tan of 25.7366 divided by 100. So we should get an answer, hopefully, of something. So we'll go inverse tan. I'm just going to copy this. Now the reason why I'm using the copied form because it's more accurate, okay? So I'm not running into problems with rounding, okay? So that's 14.4 degrees. So I'm not sure if the book rounds to the whole number, nearest whole number, so I'll just go 14 degrees. So from the top of the tree to the edge here, it's 14 degrees. It'll be the same here because it's the same. It's going to be the same angle. Now from the tree to the outermost edge, or the farthest point, we actually calculated what that value was. Remember how I solved for y? We actually need y. Okay, didn't realize that, but we actually need y. So go back to our answer. Y was 1414214. 1414214. Let's go back. So y was 141.4214, and we are calculating the angle, I'll call that beta, to the farthest edge. Okay, so if I draw a triangle, what's the angle to the farthest edge? So I know that y was 141.4214. The height of the tree was, I'll need to go back to here, it's 25.7366. 23.7366. 25.7366. So against the tan ratio, Toa ratio. So tan of beta equals 25.7366 divided by 1414214. So beta equals the inverse tan of that thing. So 25.7366. 141.4214. Let's work out what that is on the CAS. So inverse tan of 25.7366 divided by 141. So I'm just going to copy and paste. Like I said, I'm just doing this for accuracy sake. And I should get 10.31 degrees, or 10 degrees. So beta equals 10 degrees. So hopefully that helps you solve that problem. Sorry that that thing erased. I accidentally erased everything else. But essentially, you need to find this length first, and you need to find the overall diagonal length to get the angle between the furthest point to the tree and also the angle from the other point to the tree, which is the same. So it's a bit tricky because there are quite a few steps to go on with it. You needed to actually find the height of the tree first before you can work out anything else. Well, you need to find the length of the shadow first of the triangle they've drawn there, and then find the height of the tree. So hopefully that helps.